Today we have the optoNCDT 1420 laser triangulation sensor. The optoNCDT offers a unique combination of speed, size, performance, and application versatility for displacement, distance, and position measurements. The compact triangulation sensor achieves a high measurement accuracy and a measuring rates up to 4K Hertz. It also offers a unique ease of use. All optoNCDT 1420 models are operated using an intuitive web interface. From that interface, you can set up to 8 user-specific sensor settings that can be stored and expanded in the setup management. Setups can be quickly and easily saved, loaded, and transferred onto other sensors. Video signal display, the signal peak selection, and a freely adjustable signal averaging options additionally optimize the measurement tasks. The region of interest function also allows for interfering signals in the background to be filtered out. The multifunction button enables quick sensor setup for easier measurement tasks that do not require specific setups. Okay, so what we have here is the web interface that is reading the outputs from the sensor. We have multiple tabs across the top that bring up different settings, options, and windows. And then on the side, on the home panel, we have a lot of preset options that let you jump in quickly if you're just performing standard operations that don't require a lot of variance. And we have standard surfaces, multi-surfaces, light penetration, and then we have one special setup that we have created using custom settings. On the side, you can change, on this spot, you can change your signal quality to be dynamic, static, or balanced. And then on the side, we have settings that are just basic overview settings that you can change later, but you can't change from this tab, but you can change them from this settings tab, which features a large variety of options. Once again, we have something that talks about which, what are we measuring, what are some presets we have to take into account for those, your measuring rates, input triggers, ranges, peak selections, and more options. So here we have the sensor itself and the converter that is converting the RS-422 signal into a USB signal so that it can be read by my computer. The sensor is on a mount that allows us to simulate it being mounted over objects that are being run under it. Here's the metal object. Metal can be tricky for sensors, but not for the optoNCDT, thanks to its advanced algorithms and its auto-target compensation that makes it better on difficult surfaces. The sensor has sharp edges distinctly showing the fall off of where the sensor is reading it. There's a few squiggles on the end for me jostling it at the end, but overall it gives a fairly sharp representation of the object it is scanning. So another kind of object that causes problem for a lot of sensors are objects with diffusion or objects with penetration that cause the laser to hit them and not bounce back correctly because the material is causing problems. So what we have here is a white object where the material has penetration that will cause a problem for the sensor, and it will cause a problem with most sensors, and the optoNCDT can read such materials but not without one minor tweak in its settings. So we're going to run it through the scanner once with the same settings as the metal object, and as you can see here, it doesn't come out very well. There's a lot of lines are squiggly, they aren't correctly reading the object, and it would get a different random reading each time. That would cause a problem. This would not be good for something that needed to be measured because the measurement isn't accurate, as I said, but it also wouldn't be accurate each time. So this object is causing a problem for the sensor, so what we're going to have to do is make a change to the settings that are controlling the sensor, and we can do this easily from the web interface. So you just have to go up to the Settings tab and then change the laser type to Materials with Penetration. Now this simple change will allow the laser to read this object and create a good, accurate reading that can be repeated. So one more time, I'm going to run the same white object that we just saw under the sensor and get a new reading with these new settings. So now the reading is accurate, it's the correct shape, size, there's no squiggly lines, it's been read correctly, the fall-offs are sharply represented, and this reading would give a good, accurate description of any object running under it. And it would also be repeatable, meaning it could be used consistently throughout a measurement line, multiple objects, and all it took was one simple change to the settings in the convenient web interface that is easy to use, and we have a great reading now. The optoNCDT 1420 is a great sensor in a small body. The small body doesn't make any sacrifices though, as it brings together a unique combination of speed, size, performance, and versatility for displacement, distance, and position measurements. In this small size allows it to be placed in most locations, some of which other sensors just could not fit. This way, you can place it where you want and get high quality readings off almost any surface. And as we've shown, it does well with metal as well as objects with penetration where the sensor would normally have trouble reading because of how the object is not just being hit and bouncing the laser back. There's some sort of diffusion, or for whatever reason the material is causing a problem. It does all this easily thanks to its web interface, which controls the sensor. If you'd like to learn more about the optoNCDT 1420 or any of the other high-quality sensors Micro-Epsilon offers, you can reach one of our sales engineers by emailing us at sales@a-pcorp.com or by calling us at 508-351-6200, and one of our sales engineers will either be ready to take your call immediately or will get back to you as soon as possible.